maybe you hear me enough like this, or you prefer me to speak to the microphone?
Maybe just, yeah.
Okay, so Sanisphere is a French company who design, build, and install Drytoilets, vermicomposting Drytoilets. So I will present it today to you. So first of all, a short history. So it was created in 1991 by Pierre Colombo. So you can see him. He's now 74 years old man. And okay, he still sees himself and the company in something like 30 to 40 years. So keeps alive. At the beginning, Sanisphere met difficult years because the first technology developed was not at all appropriate to public use, because yeah, it's only for public dry toilets. Yeah, we faced some odor and clogging problems. And in 1995, the conveyor belt was developed. It permits to separate urine from solid liquid mix. And after, we also developed the vermicomposting process technology applied to human waste. So I will going back to these two technologies a little bit later. We faced also selling problem because, as Blaise told you yesterday, we are late in France, and in the 90s, dry toilets were not a solution for national parks, ski resorts, or municipalities. So after a drastic price raise and the improvement of all the technologies, we became to be more famous in France. We could sell some toilets. We keep on growing till now. In 2014, we are 12 employees in the company. We are more than 550 installations in France, few in Europe, and only one in North America right now. It's in Quebec. So here you can see the design of our toilets. So the cabin part for users, it's a traditional cabin. The technical area where solid waste are stored and processed. So our technology relies on three technological bricks: the mechanical brick with the conveyor belt that permit to separate urine and solid waste. The biological brick with the vermicomposting process on the fly trap to remove flies. And the last brick is the natural airflow brick to prevent bad odors to come back to the cabin. So let's see this brick more in details. So the first one, the mechanical brick. So here you can see the conveyor belt. So as I said, it permits to separate liquid from solid. It's a really important thing because for vermicomposting process, you need to remove ammonia. Worms are very sensible to ammonia. So it's really the basis of our technology. It is moved really by simple mechanical connection, and it's the user, instead of pressing a button like in a flush toilet, that press the pedal with his foot, so it's more hygienic in some way. Like that, the conveyor belt just moves around. The second part, you can wonder what is that. So it was developed, the scrapper chain, for very high rate of frequentations, because when you have the conveyor belt, after you have feces and toilet paper that falls to the conveyor, from the conveyor belt to the floor, and it make a pile. And if the pile keep on growing, it can block the system if the pile is higher than the conveyor belt height. So the scrapper chain permits to move the pile of feces to the whole surface of the technical area. But it's only for more than 40,000 utilizations per year, so that's a lot. This scrapper chain is also moved by the user at the same time that it moves the conveyor belt. This permits also to facilitate the vermicomposting process, because actually we have the pile and it's quite big, and the scrapper element, when they come back, just spread the pile, so you have less height, and it permits to oxygenate more the pile, and it's better for worms. So you have the feces on one hand, but on the other hand you have the urine that fall into a urine tray. And this, it can happen sometimes that also some solid waste fall also into the urine tray. So we developed the self-cleaning urine tray that permit to clean it after the use and to prevent that to clog the pipes by with papers or just feces. The second brick is the biological. So at the beginning, we made almost the same experience as Roger had in this yard. So, but it was in 2000. We made it in the Pyrenees National Park. So where it is, okay, it's just here in France, quite far from our location. And yeah, so it was really, the objective was really to see if vermicomposting can work in our toilets and for human waste. So we wanted to see if we obtain a good compost, the stabilization of the compost, and as well the hygienization of the compost. So we had 5 different boxes with feces plus worms, feces alone, nothing, feces plus worm plus straw, and feces plus straw only. And we had really convincing results because in all the boxes we found, as you found, good compost, but we had all of the boxes as well living worms. And the volume of all these matters were highly reduced, so that's pretty interesting as well in terms of maintenance process. The straw was found to be useful to keep wetness in it because worms need to be in the humid environment, and if it's dry, they all die, maybe. And we have also some quantitative results, and the rates of Enterococcus and coliform were highly decreased. We kept on working on the vermicomposting, but in high altitude, because in mountain areas, most of our installations are above 2,000 meters high. We didn't dare to use the vermicomposting process because we were afraid that all worms died or that just it couldn't work. And so that time in the French Alps, we installed also boxes at different altitudes from 1,600 meters to 2,600 meters during 3 years. And also, these results were quite convincing, except in one box where worms were all eaten by marmots. But in all the other cases, we found also good compost, but with a big difference between the altitudes that the process were more or less fast. Meaning that during winter, worms are in dormancy, and so they don't die, but their activity is very low. And depending on the altitude, this period of dormancy is more or less long. But anyway, at the end of the summer, you find some compost. So that's a good thing, and now we want maybe to do this other experiment higher, between 2,500 meters or maybe 3,000 meters, but maybe we want to test different kind of boxes, maybe insulated boxes, to see if there is something different, and so. The biological brick is mainly on vermicomposting, but also we try some other stuff, like we test other organisms, like a snail, Zonites algirus. It was found in the south of France, and its common name there is shit eater. So a good name maybe, and a good candidate, but we still need to test it. We also, in all of our installation in France, we found many wood loses, and so we wonder if they have a role in the composting process. And maybe they can have a role of co-composting with the worm, that a scientist from France analyzed the compost, meaning the sheet of worms, finally, and he finds that woodlouse eat that. So we have not a lot of results yet, but we want to see if they help in the stabilization or hygienization of the compost, maybe both or maybe none. Let's see. Another part is we speak a lot of feces since the beginning of the day, but what about urine? Urine is the most of the case sterile, but it can be not. Today we have a lot of problem of drug component, thank you, into urine. And maybe after it can cause some problem in water. So we begin to have a research project on it. And one thing that is promising is the struvite recovery. It's a component made of phosphate, ammonium, and magnesium. And so it is contained in the urine. And this is the component that creates some clogging problem. And maybe we are trying to find a simple system to help the precipitation of this component before going into the pipe. And it could be also reused for agricultural purpose, as there is some some phosphor and some ammonium in it. But that's just the beginning, so I can't give you more details about what we have done there. The last part is the fly trap. Some years ago, in some station, we found many flies. It was really a problem for users. And so we made a study on this fly, and we found that it was mainly female flies that came into our technical area to lay their eggs. And so we developed a fly trap that you can see here. It's really easy. Flies are attracted by light. They came into the hole, but after they can't go outside. And so when they die, they just fall into the bag. And when you do the maintenance, you just have to empty the bag, and that's all. And it really reduces the amount of flies into the technical area. But moreover, for the last brick, the natural airflow brick, we have to be very airproofness, so now we don't find any more flies into our building. It's very rare to find some flies into these traps. So this last brick was developed the last 5 years, I would say. Before we used some fans to prevent bad odors to come back into the cabin. And these fans were plugged on photovoltaic panels, but you know, it's France. So most of these, most of these panels were stolen. So problem of vandalism, problem that no battery, no panels, no electricity anymore, so bad odors. So we tried to find a new way without electricity for building. So we developed the natural airflow bricks that I think it's also used on the toilet here in the USA. And so to have really just one movement of the air from the cabin to the technical area only, and not on the other side. And it works quite well, actually. We had just had to do some building modification, really easy, with polycarbonate panels on the roof for greenhouse effect to warm the air, and also just to guarantee really the airproofness of the technical area, because if the air goes on the other way than through the chimney, it can smell bad. And also we change the size and the shape of the chimney. To improve this brick, we have in the garden of the company 2 little prototypes with many sensors, and we make some experience on building modification on it before testing it in real. So that's the 3 bricks, and it led us to our different products. Actually, before 2010, we had only 1 product. Now we try to diversify our range, depending on mainly on the frequentation of the site, and also on the localization. So we can propose some products ranging from 3,000 utilization per year to 40,000 utilization per year, with a price ranging from $25,000 to $90,000. It's quite expensive, but then the maintenance is very low. So I will present you really quickly our different products. So here it's the biggest, it's called the Sanimax. It was developed for highways rest area in France, and it's equipped with a scraper chain. This building is 4 meter width and 5 meter length, and it was developed during a European project with a German company who developed a biofilter to help removing bad odor into the building, because here you have a very big amount of shit to treat. So the second model is Sanivert, and it's the historic model. So it's for moderate to high frequentation of 8,000 to 15,000 utilization per year. And it's adapted to every site almost. The Sanitaire was developed in 2011, and the main difference with the Sanivert is that it's a little bit smaller, and the building is a little bit different because it's plywood instead of cladding, and it has 2 different colors, with light colors on the cabin side and dark colors on the technical area. This model this year was also developed in kit for export during this European project. The Sanilite, which is quite new because it was also developed this year. This specificity is that it's more smaller and it's very simple. The conveyor belt, instead of being fixed under the roof of the cabin, is directly, we can say, plugged into the toilet bowl, so it's more compact and it's really useful for small frequentation only. It should be soon in kit as well. Here's our last product, the Sanitrack. This one is really dedicated for remote sites that can't be reached by a truck or by on road, because it was developed to be transported by helicopter. The rate of frequentation can be from very small, 2,000, to quite high, 20,000 utilization per year. And we have also, for sure, different model. The other part is that on all our models we have the access for people with reduced mobility, but not on this one. I think that maybe if we need to bring it by helicopter, people can go into the toilet. So to finish, I'll show you some examples in mountain areas. They are all located in the Alps, French or Swiss Alps. So the first one, it's located on the Mont Blanc at Valo-Hut, and it's our highest toilet because it's at 4,400 meters. And here, so vermicomposting process is not possible at this altitude. So we use the ancient system with still the conveyor belt, but then solid waste fall into a carousel that is also activated by the user. It turns to fill all the bags in it. Here we need electricity to dry with some fans feces. And then bags are just removed only once a year, something like this. So this is very special because it's a wooden frame, but after we have some metal panels to resist to the tough conditions there, because we can have a temperature around minus 40 degrees Celsius. Sorry, I don't know the translation in degrees Fahrenheit. And also you have a lot of wind. Here it's in Switzerland. We also propose some integration in the existing hut, and it's also very high. So it's again the drying process that I've just explained to you. And here you can see the cabin, but it's just in construction at this time. There will be some separation between all the different toilets. So here we go to more traditional product with Sanivert and the vermicomposting process. It's in France. The last one, it was just installed something like 2 weeks ago. And it's a Sanilight, but with a mountain version that is reinforced, especially to resist to snow and wind. Okay, thank you for your attention. And yeah, just one thing, that's not me on the toilet. It's our technical director.
Sorry, go ahead. So the last one, the Sanivert that you just showed there.
This?
Yes, that one.
Yeah.
So is there a chamber underneath? I'm wondering about if it's on rock, then does it have to be elevated?
No, I think yeah, it's true that I hadn't said it, but you have a buried part on our building, and so yeah, you need a shovel to remove the part, and then just put it in.
So if it's on a rock surface, then it must be taller. Can you?
Yeah.
To have the chamber above ground.
Yes, the higher of this part under the cabin depend on the frequentation. If it's small, you don't need many. Here it's only 30 centimeters here. But for the big, at the Sanimax on the highway, it's more than 1 meter high. Yeah.
The very high mountain installations.
Yeah.
Is the urine just going on the rock?
In this case, yes. It's not a better solution, but yes.
Maintenance requirements?
Sorry?
The maintenance requirements?
That's a good thing of our product, because you need to. We actually do the maintenance in France, and so normally it takes less than 10 minutes per year. Except the cleaning of the cabin for sure, because you need to keep it clean if you want that user use it. But I mean, the technical part on the vermicomposting process, worms are really independent. They live their lives, and so normally you have nothing to do. Other question? Okay, thank you.